So hello everyone, in this video we are going to discuss about few of the basic concepts which we will be needing to get started with data structures. So before we get started with this video, I want just all of you to consider this point. If you like this video, please subscribe to the channel and like the video and share it with few of your friends if you find it helpful. And if you don't find, you can comment, always comment down what you liked, what you didn't like. Okay, so let's get started. So if we'll go with few of the things here. Okay, I have written down some few of the points which we will be needing before we get started with any statistics algorithm things. Okay, so first of all is the flow of learning. Flow of learning. What is the flow of learning? The thing is, okay, in your elementary classes, you have like in your 10th, in your 12th, all of these. If you are from like mathematics background, and even if you are not, even if you are from commerce background, whatever, you must have studied like few basic concepts. What are those concepts? Like, like polynomials, polynomials, exponents, exponents, log, maybe some like graphs, graph tracing, maybe. Okay, tracing like, okay, what is the graph of e to the power x? What is the graph of, let's say, log x? What is the graph of, let's say, um, anything like x square, x cube, whatever it is. Okay. So you must have studied these things. Apart from that, you must have studied about the probability, and etc. It is okay. So um, you must have studied about these things. Okay. So so you'll say, Anuj, what is the point of like having these things here, like these polynomial? Yeah, we have studied it. What it makes sense here? Uh, how we are going to use these things in like in this data structures and algorithms. The thing is that each and every section of data structure algorithm is dependent on these things, these few basic things, not like the higher order mathematics is not um, dependent on. It's majorly dependent on the basic mathematics. When if someone has studied like the BO notations and all that, okay, let's go into it later on. Okay. But okay, you got the point that you need a bit of basic mathematics. Then, then what is about? Then we have the programming languages. Now, why do we need programming languages? The thing, the next point we have is programming languages. Okay. You can have any language. Okay. But do we need a programming language to for data structure algorithm? In real sense, you don't. Why? I'll tell you. I've taken an example here. You have a task of going from your home to the nearby market. There are some checkpoints in between, and you can go from your home through these checkpoints. These are kind of like routes in between. These are routes. Yeah, these are routes. So uh, these are the like two checkpoints which you consider. Okay. So one of the things which you will have, you don't want to waste a lot of time. Obviously, you will not because, oh, because you want to go somewhere else, or maybe. whatever it is, don't want to waste a lot of time. Again, the next thing is don't want to remember a lot. Let's say you are not using Google Map. In that sense, what you will do? Will remember the path. You will learn the route. Okay, I want to go left from there, right from here, straight from there. Yeah, you'll remember these points. But the thing is, if you remember too much, there is 100% possibility you'll make an error. If you have not went to that market earlier, you'll make a mistake. So you don't want to remember a lot. So in that sense, you will take the shortest path. You will take the shortest path. Okay. Let's say whatever is the shortest, like one, two, three. Okay. So let's say this is one, this two, this three. So the length, uh, if we say the length here, here the length from A to B, that is shortest is equals to 3. Okay. Equals to 3. Now, maybe you can take another route like one, two, three, this three, one, two, three, that's also 3. Then you have like, let's say one, let's say you go from one, two, three, four, 5. That's long. Okay. So you will not take that route. So what you will do, that's, so you will take this path, you will learn this thing. Okay. And if someone have studied this thing earlier, you'll understand this thing that this time thing is your time complexity. This is what is your time complexity. Okay. And you don't want to remember a lot. That is your space complexity. Complexity. Maybe uh, this will not make sense right now, but yeah, this is the time complexity, and this is the space complexity in sense of technicality. You want to consume the least time, you want to consume the least memory of your mind to actually reach to the point where you want to be. So that is what the space complexity. So if you look in that sense, if you want to understand algorithms, any algorithm, okay, or let's discuss this one. What is an algorithm? What we have discussed earlier, like you want to go from your home to the market, that is an algorithm of how you will find the shortest route and how you will reach to the market. So steps of doing anything, steps of doing any task is the algorithm. Okay. Second, जो चीज हम कंसिडर करते हैं, okay, the thing we consider is the efficiency. Efficiency. And here if you see, you have defined two parameters for yourself. That is time and remember. That means constraints. How an algorithm performs, okay, how an algorithm performs under certain constraints. That is the efficiency. Okay. So these two are like the points we for the algorithms. And in actual sense, you don't need a data structure or to understand algorithm. You can directly understand because okay, have have you seen yourself doing like this? Ki, okay, I'll apply that algorithm to like to reach from home to market. No, you directly do it. That is why I said you actually don't need a programming language to actually understand these things. But the thing is, you will be able to do these things only in real life. When you are working with computers, you need the programming languages to actually communicate with the computer. Otherwise, you can like use these algorithms directly in your daily life. That will also work. But obviously, these algorithms are like what do you say, actually made for computers. So it doesn't make any sense that humans do these things. Okay. Okay. So the next point we have is the data structures. So after programming language, whatever you have chosen, let's say you choose, I have written like few examples here. You can choose like C++, Java, Python, JavaScript, what else, but whatever you choose, it doesn't matter here. Okay. Then we have the data structures. Data structures. So uh, we'll discuss this point here. So obviously, like if you go for data structures and algorithms, the next 2 points which you have like third point that is data structures and fourth point that is algorithms. So these two things in act, these tools are actually implemented, actually studied. When we study, we'll use pseudocode, and when we will implement, we'll use a programming language. Okay, programming language. Okay. Otherwise, it doesn't make any sense that if we can't use that algorithm to actually solve a real world problem, it doesn't make any sense. So that's why we will be using these things. Okay. So yeah, these are the prerequisites which you will be needing. Your like elementary mathematics, your programming language, your and data structures and algorithm we will be studying. So it doesn't make much sense to actually uh, discuss these points here. Okay. So we will get started with today's video's topic, that is the asymptotic analysis. So our today's topic is asymptotic analysis. Asymptotic analysis. Okay. So in literal sense, if you see what is the meaning of asymptote, if you just see this thing, what is the sense of asymptote? If if you have studied like few graphs, let's say if there is a graph, let's say any graph, maybe I make this. Okay, it's a kind of hyperbolic graph. Okay, so if you see these 2 points, if you have seen in hyperbola, what happens that this line meets this at infinity. So that is what we have, asymptotes. Asymptotes. These are the tangents. Now this is getting more technical, but okay, this will help you. Like you know now that e to the power minus x. Let's say e to the power minus x. This graph goes like this, and it meets the your x-axis at infinity, meet at infinity. Okay. So what is it? Like asymptote is just like the value, or you can say which is touching at infinity. Okay. So I'm just making like a connection between like the mathematical sense and this sense. Okay. So this now the next you can say the next analysis which you can take is, as we have studied in our last example, okay, as we have studied in our home market example, example, okay, we have taken two constraints. Okay, the first one was time, second was not to remember a lot. Remember a lot. Okay, this time not to remember a lot. So if you convert this into like in the technical sense, this was the time complexity, and this was the space complexity. So why we needed the asymptotic analysis? Why we need it? If you look at our earlier example of like home to market example, you'll see that you need these two things. You don't want to remember a lot and you want to take the least time. And this is what we do with the computers also. If the computer is going to take so much time to calculate something, it is a waste of time. Like if you want to go from market, or maybe let's say if you want to go from your home to market, and if you are taking let's say 2 days, 2 days to just reach the market, so it doesn't make any sense. It's not even useful. If you take like 2 days, it will be useful that you will do that time in 30 minutes. Do that task in 30 minutes. That is useful. This is useful. This is useless. Okay. So that is what happens with the algorithms also. Computer is also kind of a labor, kind of a person which does our task on behalf of us. Okay. So this was about why we need time complexity, why we need space complexity. If you want to remember, let's say, a lot, and if you are going to make a lot of mistakes, it doesn't make any sense. And that is like the most simplified with complexity. If you take like too much space in your hardware, it's a waste of time, waste of energy also kind of. If you see like, well, if you see in literal sense, it's kind of waste of energy also. So So what exactly is time complexity? What exactly is time complexity? Time complexity is defined as the time taken by the algorithm. No, it's not time taken by the algorithm. Time taken is not equals to time complexity. Complexity. Okay. Because if you have a let's say old machine, this is an old machine. and this is a new machine. Obviously, there is a sense that, okay, this will load things faster, this will load things like this will take a lot of time, take a lot of time. This will take less time. So obviously, the older machine will be having like let's say it will take like 20 seconds to do a task. It will take like 1 second to do that task. So does that mean that our algorithm have failed in this sense and in this sense? No. The time complexity is defined as it is defined as the rate of change, as the rate of change of rate of change of time taken with respect to the input size. It says you have input size here, input size, and this is let's say time taken. So this is your graph here. So as you increase the input size, as you increase the input size, that says I denoted by n. So as you increase the n, and I'll show it with let's say t, t will also increase time. Time will increase. Time taken will increase. So the best parameter which you will be having is take is the slope. That is this theta. And this is the time complexity. Time complexity. So till now you must have understood that if your machine is taking too much time, that doesn't mean your algorithm is failed. It's just that that machine is taking time. It's not like algorithm is failed. Okay. It's just like uh, let's say if you have two machines, then the algorithm will give the same slope of graph. Obviously, it's going to take like there will be some variations, like someone's gonna like this, other maybe graph will be like this, or let's just whatever it is. But the thing is, ultimately, this complexity will be same around. Okay. Okay. So this was about the time complexity. How you judge it, we'll see later on. Basically, if I cover it here, you'll understand it. If you have, let's say, you have like this kind of technique also that if you have, let's say, I cannot surely say, but if you have just like one for loop, let's say this this is the working space, and if you just traverse it once, then it's a linear. If you let's say if you traverse this twice, if you traverse this twice time, then it is O of 2n, which is essentially of O of n. Okay. And if you traverse it like for every block, if you have traversed the whole array, then it's of n square. Okay. We'll discuss it later on and we'll be studying like the main algorithms, but you will get a bit of idea here. Okay. Now, the next part, we'll see. There's the space complexity. Space. So next is the space complexity. Space complexity. Okay. So why have written it in like these like colorful pen? I have written it because there is something special about space complexity. But don't go into like this sense of like why the name is like space complexity and it is like very fancy name given to something like taking space. It's a like it's just a fancy name given to this. The basic sense is how much space is taken in the hardware. Okay. So for every algorithm, let's say you made a function. You must have made a function in like in any language, like which you like end in, then you have like a return, let's say n into n, let's say n square function. Okay. You must have made like these kind of functions in C. So if you see, this is the input input space which you are giving to it. So what is it? It will take some space. Okay. Let's say it will take some input space. But here you will see there is n square, n into n. This will be stored somewhere. So this is auxiliary space. And these are just fancy names given to some simple things. These are just fancy names given to some simple things. In a real sense, what you will see, the extra space which you are taking in solving a problem, solving an algorithm, like in this sense, you have this as input, this as space. So n into n, let's say if the integer is small, it's going to take, let's say this take 2 bytes. So this will also take 2 bytes. So total will be like 4 bytes. Okay. So, but we don't generally consider the input. We don't generally consider the input because input is like undecisible. Input can be anything, okay, as large as anything. So we don't consider input. We just consider auxiliary space. Auxiliary space. So in the above example, we'll have auxiliary space as 2 bytes, and that's all. This was just like overview kind of thing about um, the space complexity, the time complexity. In just a quick sense, you will understand like what is space complexity, what is time complexity, what is the use. We have discussed like few real world examples here. Oh yeah. So these videos, this will like give you like few a bit of sense like okay, this is how this thing works, this is how that thing works. These videos are not kind of that it will supplement everything, okay, but these are kind of like short pinch of salt which you can use here and there, and you will understand like okay how things actually works. So I'll end this video here and I'll see you in some next video. Till then, bye bye.